Hello everyone. Today we will learn about the ultrasonic inspection of welded joints. The ultrasonic testing of welded joints is more complicated than ultrasonic testing of sheets, forging, casting, etc. We divide it into several parts while talking and operating. 1. Preliminary knowledge. 2. Inspection implementation. 3. Defect evaluation. 4. Test report. The first prerequisite knowledge is the detection area. The so-called detection zone refers to the area that needs to be detected, which includes weld seam and heat-affected zone. Different welding methods have different heat-affected zone widths. In order to accurately know the width value, we can only measure the hardness or observe the metallographic structure. Usually, it is specified as a fixed value in the non-destructive testing standard. For example, it is specified as 10 mm in the standard MB/T47013. 2. Probe moving area. The probe moving area is the area that the probe has scanned on the base metal inspection surface during inspection, and the width of the probe moving area shall at least ensure that the ultrasonic beam can scan all detection areas. It is easy to obtain the theory, and it is 0.75 times the span when detected by the direct method. When detected by a refraction method, it is 1.25 times the span. 3. Scanning method. Ultrasonic inspection of the welded joints should first use a zigzag scan to find defects. When a defect is found, the front and back, left and right corner, and surrounding scan methods should be used to find the highest echo of the defect. The longitudinal length of the defect is determined by scanning left and right. The following describes the inspection operation essentials of welded joints one by one according to the inspection process. 1. Select the probe correctly and measure the leading edge length and K-value of the inclined probe. The selection of the probe includes ultrasonic frequency, wafer size, and the K-value of the inclined probe. These parameters mainly affect the detection sensitivity and defect detection rate. Generally, there are corresponding provisions in the implementation standards and operating instructions. Their determination was described in the previous video and will not be repeated here. 2. Calibrate the time baseline of the instrument and determine the appropriate scanning speed. Place the probe near the center of the arc of the CSK-IA test block with a radius of 100 and slowly move the probe left and right until the highest echoes of the two arcs, R50 and R100, appear on the display. Note that the wave heights shall not be lower than 20% of the full screen height. Fix the probe and adjust the pulse shift and depth fine adjustment knobs so that the horizontal scale corresponding to the two echoes is in a 1:2 relationship. Then turn the probe to probe the transverse hole with a depth of 15 mm on the test block. Adjust the depth fine adjustment knob so that the echo scale is at 1.5. At this time, after adjusting the scanning speed according to the depth of 1:10, lock the pulse shift and depth fine adjustment knobs. Let's start draw the DAC curve. The base metal thickness of the inspection weld is set to be 30 mm and the inspection level is B. According to the standard MB/T47013, the single reflection method should be used for detection. So the buried depth of the artificial reflector corresponding to the DAC curve should cover 2 times the thickness of the workpiece, that is 60 mm. Use the same method to measure other depths of 20, 30, 40, 50, and 60 mm transverse through holes and make a mark at the wave crest at one time. Finally, connect all the marked points smoothly. The DAC curve is drawn. Next, determine the sensitivity. According to the standard, the detection sensitivity shall not be lower than the evaluation line. Reduce the attenuator reading by 18 dB plus 2 dB surface compensation, a total of the 20 dB. This is the evaluation line, which is the detection sensitivity. Draw the detection area and the probe movement area on the workpiece. Increase by 6 decibels again. Use the scanning sensitivity to perform zigzag scanning with an oblique probe. There are a few points to note. 1. The adjacent scanning area should overlap at least 15%. 2. The probe should swing 10 to 15 degrees from side to side. 3. The scanning speed shall not be faster than 150 mm/s. When the echo amplitude on the display screen is higher than the evaluation line, mark the workpiece by excluding surface defects through defect location information. Awaiting a further testing. For the marketed position, press the detection sensitivity again to detect. Use front and back, left and right, and surround scans to find the highest echo and record the corresponding defect position and echo amplitude on the record sheet. The recommended style of the record sheet is shown in the figure. The recording of the defect position adopts the coordinates method as shown in the figure, and the recording method of the echo amplitude is EL plus how many decibels. Use left and right scanning to measure the defect length and record it. It should be noted that if the wave amplitude exceeds the quantitative line and the wave height has only one highest point, use the half wave height method to measure the length. If the wave amplitude exceeds the quantitative line and the wave height has multiple extreme points, use the endpoint halfway height method to measure the length. If the amplitude only exceeds the evaluation line, use the evaluation line absolute sensitivity method to measure the length. In addition, the Cartesian coordinate system is established on the workpiece, and the coordinates of the defect are measured and recorded as the final defect position. Lateral defect detection is described below. The detection sensitivity of transverse defects should be 6 dB higher than that of the longitudinal defects, and oblique parallel scans should be performed from opposite directions. The other defect recording methods are the same as above. When all defects are detected and recorded, the quality of welded joints shall be evaluated in accordance with the acceptance criteria, and a test report shall be issued. The content of the test report is mostly the same as that of the record sheet. The difference between them is that the defect record only records the original data during the inspection process, while the inspection reports contains the quality level conclusion made by the inspector according to the standard. Okay, the demonstration of the ultrasonic testing process of welding joints is completed. Thank you for watching.